So far, we've been able to calculate probability by counting the number of outcomes. We can also use the idea of sets to help us determine probabilities for various events and various combinations of events. So we know that this is true from before. And so by our definition of probability, the probability of A or B is equal to the number of elements in A or B divided by the number that's in our sample space. So we can extrapolate this by saying it's the number in set A plus the number in set B minus the number of elements in the intersection over NS. And then we can divide this into individual fractions using our algebra knowledge. Which we can extend to this probability statement here. So the probability of event A or B is equal to the probability of event A plus the probability of event B, take away the probability of event A and B. So it works the same way as our counting of elements in sets. So for example, one card is drawn from a standard deck of 52 cards. Find the probability that the card is a club and it is even. So probability of a club and it's even. How many possibilities do we have for that? Well, we've got 52 cards to choose from, so that would be our total. I know that I have 13 clubs, and out of those 13, I've got the numbers 2, 4, 6, 8, and 10, which are even, so a total of 5 elements in that set. So now if we extend that to finding if the card is a club or an even number, so we've got club or even. Now we can use our statement that we derived above. So we would have the probability that the card is a club plus the probability that it's even minus the probability that it is a club and that it's even, which we found in part A. So the probability that it's a club would be 13 out of 52. The probability that it's even would be 20 numbers out of 52, right? So I've got 5 cards per suit that are even times 4 suits. And then I'm going to take away 5 out of 52, which was what I calculated above for the probability that it's a club and even. Evaluating those is going to give me 28 out of 52, which I can reduce to 7 out of 13. The last one I'm going to do here with the cards is that a club is an ace or a 10. So I've got an ace. Ace or a 10. So we would have the probability that the card is an ace plus the probability that the card is a 10 minus the probability that we have an ace and a 10. So the probability that the card is an ace would be 4 out of 52. The probability that the card is a 10 would be a 4 out of 52. And then we need, we're going to take away the probability that the card is an ace and a 10. None of the cards in a deck fit that criteria. So this would give us 8 out of 52, which is going to simplify to 2 over 13 is our probability that the card is an ace or a 10. I'm going to change this to card. So we can also extend this formula to 3 events. So if we have the probability of A or B or C, it's equal to the sum of the individual probabilities, subtract the intersection of the 3 probabilities, and then we're going to add the intersection of all 3 events. So let's figure out the probability that the card is a club or an even number or greater than 5. And our ace is going to be low in this case. So we would have the probability that the card is a club or an even, or greater than 5 would be the probability that we have a club, plus the probability that it's even, plus the probability that it's greater than 5. And now we're going to take away our 3 intersections. So we would have take away the probability that is a club and even, take away the probability that is a club and greater than 5, take away the probability that it is even and greater than 5, and then we have to add on the intersection of those 3 events. So club and even and greater than 5, just keeping my notation consistent here. And now we can fill in all those pieces. So our probability that the card is a club is 13 out of 52. The probability that it's even is 20 over 52. Then we've got the probability that it's greater than 5, which is 32 out of 52. So in any suit, you have 8 cards that are going to be greater than 5, 6, 7, 8, 9, 10, Jack, King, Queen, because the ace is low. And then you're going to multiply that by 4 suits. Then we're going to take away our intersections. So club and even is 5 cards, as we determined above. Club and greater than 5 is going to be 8 out of 52. So that would be 6 of clubs, 7 of clubs, 8 of clubs, 9 of clubs, 10 of clubs, and then the Jack, Queen, King of clubs. Then we're going to take away the idea that it's even and greater than 5. Okay, so reducing our 20 out of 52 number. And then our last one is the intersection of all 3, which is only 3 numbers out of a possible 52 in that set. So adding all those together would give me 43 out of 42. That would be the chance that the card is a club, or it's even, or it's greater than 5.